Good afternoon. My name is Young Baek. So you are very long time waiting. This is last presentation. So for your warm and delicious dinner, I try to quickly finish. So yeah, this page skips. So so one of the interesting is that before 1995, we have also the red tide bloom, but not too much serious because of the red tide bloom is the species diatom. But after 1995, we are changed everything. It means the species change from diatom to the dinoflagellate. The main occurrence area is the south coast of Korea. But sometime many years is transport into the east coast. Sometime in the west coast. One of the very important phenomena is the geographically unconstrained. It means some red tide bloom occurred sometimes in very turbulent area, sometimes occur in the very clear water. Maybe you can show the frequency of red tide occurrence. You can see. I think you can find where is the hot place. Maybe the red color indicates very dominantly occurred red tide bloom. So one of more interesting. So in the 1985, so bloom started in the middle of the some August, and they finished October. But now you can see here. So bloom started in the July. Finished this around the September. I think it's the bloom is a shift. So maybe we have lots of some control factor or physical mechanism. But I think one of the control factor related to global warming. Because according to my result, research result showed here, around 1985, so you can see this is the sea surface temperature. It's a summer line. It's a black line indicated so far from the Jeju. So but now you can do 2009, very close to Jeju Island. It means some sea surface temperature increasing. So according to my research, some sea surface temperature increasing about 1 and 2 degrees Celsius during the 30 years. So you can see this here. So I have lots of questions. So we can detect the red tide bloom from space. We can monitor the red tide, we can distinguish, we can trace origin path of red tide. What is the physical forcing factor? So I tried to understand red tide outbreak. I used combined study. It means I used INSURE's hydrographic simulation data and some satellite data. Also we used the reanalysis data. So I give you some in-situ observation in red tide occurrence area. This image shows some red tide bloom area. So in general, depend on the sea status. So cloudy or the sunny day. So in general, color is some dark brown. But in the high density case, you show some red color. Did not clear, but there's some very high density some red tide bloom. So if you go to some red tide survey, in general, we are difficult to detect red tide bloom because sometimes depend on the sea status very quickly changes. So we are difficult to detect some using the eye. So we used the real-time measurement method. I mean, it's you got to use the 10 AU measurement. This is detected the fluorescence of the phytoplankton. So immediately we research vessel moving. We are get the real time get the water sample and using the water pump and pass through this 10 AU machine and check the fluorescence value. It means we are going to some survey. That time we have got high fluorescence value. We are stop the ship and get the water sample. Also we are carry out the optical measurement. So this figure shows some ship track and this color indicates a fluorescence value. So you show the 1, 2, 3 is we are get the high fluorescence value. So look at the here, very similar the chlorophyll concentration. But number 1, number 2 show the some cocoidal bloom. but number 3 has a diatom bloom, is a different bloom. So we are checked the optical property with remote sensing reflectance. So check slightly different. It means based on this approach, you can understand different optical property. Depending on the dinoflagellate, the diatom is different optical property. So we gathered some in-situ data from the optical property, means some optical environment of the some. First, red line indicates lead tide sample, blue line indicates non-lead tide case from the in-situ data. So optical environment of the some detectors and Situ absorption is very similar. It doesn't matter it's a lead tide and non-lead tide case, but you can see the pyroplankton absorption is very, very different. In the lead tide species have the high pyroplankton absorption. So maybe this absorption influences to the remote sensing reflectance. And you can see here different spectral characteristics. Spectral pattern is very different. So based on this idea, we can use the satellite or we detect the lead tide bloom. So classification of lead tide species. So in general, satellite remote sensing method so usefully detect some and monitor the lead tide bloom. So anyway, you showed some different name is the proposed satellite proposed lead tide detection algorithm using the satellite. BP model SS. We have lots of some detection algorithm. Anyway, you can see this here. So accuracy is less than 30%. So one of the example, this is BBP model is a very high detectability, but you can see here most area estimated as the lead tide. It means the pulse signal. So because most algorithms did not developed based on the optical property of the lead tide species. So our goal is that we are trying to develop algorithm based on some optical property of the lead tide bloom, majorly Coccoloidum polychoides. So we are cultured popular and the lead tide species in Korean water. Coccoloidum, Acacia, Alexandria, Scripsa is a popular lead tide species that we are cultured in the laboratory. We got some sample. So we make this model simulation. So we got generated simulations large remote sensing reflection data for the two cases. One is HAB species case, one is the non-HAB case. We are to try to compare what is different in the HAB case, non-HAB case. So we used HAB species in the previous 4 different species. Then another lead tide case, we used IOCG simulation data, and then we combine the data that is simulated, and finally we get some remote sensing reflection data. First, we checked some absorption, pyroplankton absorption. So absolute value, you can see the slightly different, but we have checked, this is a major HAB species, but we checked the difference, but we found that everything is very similar. It means all dinoflagellate species and the HAB species have the similar peak or some similar spectral characteristics because they have this almost similar pigments. So we can difficultly discriminate it. But we found the difference. HAB species, but another non-HAB case. So you can see here, this red color indicated some lead tide species in the Coccoloidum polychoides, but the green color is the non-HAB case. In the low chlorophyll concentration, we can typically discrimination, but increasing chlorophyll concentration, this difference is increased. So it means some increasing chlorophyll concentration is you showed some depression over here. So maybe we can discriminate the chlorophyll. We can discriminate some HAB, non-HAB case. We can do that. This kind of some pattern. So anyway, we checked some among the in-situ model cellular data. This image shows us captured the lead tide in the offshore. You can see here some of the patch of the red tide. This is some coastal area. You can see maybe you can see this discolored water, and this is around the aquaculture. So all of the red tide covered in aquaculture. Anyway, it showed us some body size RGB image 250 resolution. You can see there is a very huge crocodile volume in the offshore. It's a very clear water. So we also try to compare the satellite data in Situ data, compare the satellite data, simulation data. We merged all data set. It showed us good agreement and some contribute to the optical property for the crocodile polycricoides. So another case showed some coastal areas, red tide bloom, also similar result we got. So our goal is that in general, the NFRD, the Korean government agency, they provide the red tide report, but they showed some around the coastal area, did not show this offshore. So we are using some satellite case, we can detect some offshore red tide. This is what is chlorophyll A image, but we develop algorithm with the pixel-based red tide detection algorithm. So we can black dot is showing this is related to crocodile bloom. So we can estimate offshore bloom. And one of our final goal is to understand the red tide occurrence using the big data. Based on our previous data set, we will try to understanding physical forcing factor to control the red tide bloom. This is a very simple red tide dispersion case. So 2012, the main occurrence area is the south coast, but in this year, red tide occurred in the west coast. 2013, you can see here, red tide is transferred to the east side. So we are trying to check the large data set. It means check the sea surface temperature, latitude flux, or also wind, something. But anyway, we checked some wind. So maybe we have lots of control factor. But I checked the wind case. So 2012, look at here, September, August, we showed some strong, it means some southward wind. Those southward wind is strong. I think it's late to move to some west coast, but 2013 you can hear. So you can hear is a very strong southerly wind. So almost blow up the 1.5 months, it's continuous same wind. The same wind blow up here, so maybe some red tide bloom, I think it's moved to the east side. Maybe lots of some control factor, but in this very simple case, so you get lots of data, I mean some cell density, some sea surface temperature, wind direction, wind speed, or some climbing index, something we gathered, so big data set. So we have some long time series analysis. So we are understanding what is the physical forcing factor, but it's some long data set. We are very, very difficult to understanding. So anyway, we make this very simple relationship between the red tide occurrence and the physical forcing factor. We make some climatological mean. So we showed blue line indicates the cell density. So it's red line is PA, and the blue line in the sea surface temperature. The purple line indicates the tidal range. So you can see that maybe PA is increasing, and the drop in this is the summer. We have a raining season, drop the PA. So anyway, the cell density increasing starts with increasing PA and the sea surface temperature, and the increasing with the tide range, and the drop in the related to the sea surface temperature drop and some PA. So I think it's a very simple approach. It means some cell that is that red tide bloom is I think it's related to some sunlight and some sunlight energy and some some physical forcing in the tidal current is a very important factor. Anyway, we needed more study, but this is some basic this approach, we can do understanding of what happened in the south coast in area, the red tide bloom. And thank you.
So, do you have any questions? We will have just one person.
Yep. Nice talk. Thank you. As you may know, most of the Korean peninsula is cemented by well-paved roads, concrete buildings, and well-arranged river banks and so on. Thus, input of weathered sediments to the Korean coastal waters are very decreased and may result in coastal erosion as well as other phenomena such as including harmful algal bloom, assumingly. So how do you think about this very fundamental geological effect of decreasing sediment input to coastal water on HAB occurrence?
Difficult. So I don't know exactly. So but human impact is some of the important, but the recently I think the natural impact also in this global warming, or another impact in some ancillary projects, some supplied some nutrient. I think this is a more important issue. So I don't know exactly, but we showed the long-term data set, so we are trying to understand it, but I don't know exactly about that. I think it's more some study.
Please.
Yeah, the decrease of sediment load to the coastal water is decreased about 10 to 20 times. Yeah, very decreased. So I think that the decrease of suspended sediment to the coastal water may affect on the HAB occurrence and as well as coastal erosion.
Yeah. There's one example in this area. China is the Yangtze River, so there is constructed 3 gorgeous dam. So that time the decrease of the sediment. That time in around the Yangtze River mouth, so we have the increasing of red tide. It means the decreases the suspended sediment. It means the increase of the red tide, because red tide species sometimes get some suspended sediment. It means some silt and clay as a mineral so attached. At that time, some you know that some species sink down, some disappear. But it means that this area to disappear, decrease of suspended sediment. It means some increases some red tide bloom in the China Sea in the west. Maybe suspended sediment very important. Some controlling pattern. You say there's a decrease of suspended sediment. I think it's the increase of some bloom, red tide bloom.
Okay. Any questions? So thank you very much for your talk. It's